Hello. So, welcome to the morning sessions. And this first talk, I'm introducing, so it's the first talk because clearly it's about a subject that I really, really like. As many of us, I dabble in finance. I like to try and invest my money in a way that doesn't make me bankrupt. So, tools like Bloomberg in general are the most important part of that activity. And Aravind, Sethuraman, and Dhananjay, Deshpande are from the engineering team, and they're going to show us everything about how Bloomberg uses WebRTC to connect finance professionals. So, thank you so much, and looking forward to this.
Thank you, Luca.
Round of applause.
Hello and welcome to our talk on RTC in finance and how Bloomberg uses WebRTC to connect finance professionals. My name is Dhananjay Deshpande, DJ for short. I lead the RTC team within Bloomberg Engineering at Bloomberg. I'm joined by my colleague and co-speaker, Aravind Sethuraman, who is leading the RTC platform team within my group. We are both based in New York. We also have offices in San Fran. Really happy to be here, by the way. This is our first ComCon and really enjoying it. Thanks for hosting us. Before I move to the next slide, maybe let's cover the next slide and we can ask some questions. This is what the agenda for today is. I'm going to talk a little bit about Bloomberg, go into communication workflows in finance, and talk a little bit about how Bloomberg Terminal provides solutions around these workflows. After that, Aravind is going to go into some of the technical architecture, and he's going to talk a little bit about the deep dive into our WebRTC stack. We have 3 stacks. One of them is WebRTC. The other one is telephony. The third one actually is WebRTC, but it's based off Jitsi. We'll talk a little bit about that too. In the end, I'll come back talking about future work, and then we'll keep some time at the end for questions. So before I go into the next slide, a quick question around how many people here know about Bloomberg in general? Okay, a vast majority. Thanks for that. Keep your hands up because the next question hopefully will make it smaller. How many people know that Bloomberg is an engineering company and a technology company? All right, almost the same, which is great. All right, so let's move on to the next slide. So Bloomberg actually started in 1981, a little bit before I was born. It has grown to be a very large company, which is situated in 170 countries. It has about 350,000 subscribers. These are mostly financial professionals, but we are also targeting lawyers. We're also targeting news professionals, the media companies, and so on. So it's become a fairly big company. In terms of employees, it's grown to be more than 21,000 employees across these countries. And among them, predominantly, we are kind of an engineering shop. So we are more than 8,000 engineers within us. In terms of software, Bloomberg has really prided ourselves in creating Bloomberg like software from the ground up. And more recently, we have been open to using open source. And a lot of the software that we mention here is kind of representative of what we use, but this actually goes much beyond that. We've started contributing to many of these stacks. More importantly, for this conference, I think in multimedia and RTC, we do use FFmpeg very heavily. We have started using Jitsi for this product called Bloomberg Room. We do use Asterisk, and we definitely use the WebRTC stack. We are getting more involved in academic research, especially around ML and NLP. Quick question around how many people know about the Bloomberg Terminal? Okay, that's a sizable amount. Thanks for that. So the Bloomberg Terminal actually is the flagship product for Bloomberg. Many people probably know Bloomberg as a media company, as a magazine, or as a radio, and so on. But really what makes most of the money for us, about 65%, is the Bloomberg Terminal. Bloomberg Terminal actually is a hardware and software product. And it's used for multiple different reasons, but mainly for news, for analytics, for trading, and also for RTC, as you'll soon see. When you think about communication in finance, you probably think about, in movies, the open outcry system, where people are actually kind of speaking over each other and kind of yelling out prices. That's really not what it is right now, so maybe we can kind of dispel that a little bit. These are all the stakeholders and different kind of partners and the different kind of players in this market. You can find yourself here as maybe a borrower or a seller or a saver, but essentially there's a buy side, which is buying things. There's a sell side, which is kind of selling things. and there's a market, and sometimes you're actually outside of the market doing the transactions. There are also brokers who are basically helping the sell side and buy side to add liquidity to the market. And there are agencies which work with all of these different players to make the market more transparent. Bloomberg actually sits in this space where we're trying to connect all of these different players and make the market transparent for everyone. We have a few different workflows around communication within various different players in the market. As you can see, there is like a broad range of communication that happens. I'm going to highlight a few of these. So primary issuance, and I'm going to talk a little bit about that workflow in more detail, is when stock gets traded on the market. There is secondary market trading. Once it has gotten into a market, it gets traded between different parties. There's a lot of research that happens on stocks that are traded or even other instruments in the market that cover sales commentary. And there is also a lot of personal communication that happens, which kind of builds these relationships between different players in the market to make trades happen. I'm just going to talk about a few of these workflows to give you a sense of what different mechanisms are used for communication. For example, new issues. Corporations want to get money. They go out to investment banks. Typically, they use either telephones, and nowadays you use either video calls or even face-to-face meetings to actually talk to investment banks. Investment banks, in turn, want to talk to syndicate banks. Syndicate banks are the ones who are underwriting these loans and are also helping to get more kind of equity from the market. The syndicate banks, in turn, talk to portfolio managers who want to invest in these corporations. And these interactions typically happen over text chat. I don't know whether these lines are very clear to you, but at least the yellow one actually indicates telephony. But there is a line between the syndicates and the portfolio managers. And within the portfolio manager workflow, there's also a lot of internal communication, which happens over telephony, over text chat, and over video. Once the IPO happens, or if you get like a private equity deal, once you have the instruments created, they get on the market and they get sold between buy side and sell side. A lot of that communication, the initial negotiation happens, or the advertising happens on text. And then once a trade has been finalized, it actually goes to an electronic trading system or voice confirmation. A longer form of communication that is also kind of voice-based is earnings calls. Earnings calls are basically done by financial analysts or by representatives from the companies who are representing maybe a sector or the entire company. It talks about generally the performance of a company. These are typically longer calls, about 45 minutes to an hour. And what we do at Bloomberg is to really cover all of these different calls, transcribe them, and even create like automated news stories based on them. So this is a fairly different kind of use case because these are long-form communication compared to some of the other communication style, which is like short form. In terms of voice communication, it is still very much a part of some of the communication workflows. I talk a few of them. But just to point a couple of workflows which are important, there are workflows between the inter-dealer brokers and the sell side, which happen over these systems called the hauler systems, or the squawk systems, where people kind of speak to each other in small utterances throughout the day. There's also longer communication, which I talked about, like earnings calls or webinars or analyst calls, where they are like longer calls, and they need to be kind of broken down and analyzed later on. What has happened is in this industry, various different workflows are then supported by various different tools. Typically, as you can see in the screen, a trader has a lot of like screens at their disposal, also have a telephony system. So they are kind of juggling between various different screens and various different forms of telephony. And this is again a typical workflow. I'll go a little bit into what are the workflows that are supported on the terminal now. So Instant Bloomberg is our text messaging system. It is one of our flagship products. There are about 2 billion messages that go through the IB system daily. And This was kind of created early in the day, and it has become kind of entrenched in the market rubric. And many people actually buy the Bloomberg Terminal just because they want to get their hands on IB. The message system is an email system that we came up with. This was also started early in the day, even before Microsoft launched Internet Mail. And this allows people to exchange messages. Some of the workflows that are covered are price distribution, news alerts, and archival. A little bit about my group. We started off in 2011. Our mission was to basically provide high quality, reliable, secure, and compliant solutions for real-time communication. There was definitely a gap in the community where, like I said, there was like different fragmented solutions available, and we wanted to kind of have one solution which kind of gives you like seamless access to voice, to video, and to data. We used WebRTC as the foundation for video conferencing. We were at the right time, at the right point, at the right time, because at 2011 is around the time when WebRTC was starting to get adopted and to get worked on. We also used Asterisk as the backbone for our telephony applications. Our group, like I said, is based in New York City and SF. We're also part of this larger community organization that also owns the text chat system, which is IB, and the email system, which is Message. So a quick note about our products. There are a few that are noted here, but essentially there are 3 different stacks that we have built. One is based off our homegrown WebRTC stack, which we call Bloomberg Connect. IB Talk is a persistent audio chat room solution. Audio and IB is an extension of that. We are going to integrate IBT into the IB text chat as audio and IB. IB Live is our video-only solution. So actually, there's a very interesting use case where people want to be always connected to each other and see each other in a room, but not necessarily speak with them at all times. So we basically just have the videos used as presence at all times. And I'll show you a slide where you can see what it looks like. B-Share is used for screen share from Bloomberg Terminal. So all of these kind of solutions are built off Bloomberg Connect. Room is a new solution that is basically on the meetings use case, built mainly for ad hoc meetings and scheduled meetings, and it's based off the Jitsi stack. Click to Dial is a solution which does partly use the Bloomberg Connect architecture, but also is its own relay, which is the Asterisk relay, which is used as the PBX as a foundation. So this is a crucial aspect of what we are doing. Compliance has become more and more important. With the advent of various different laws and regulations, especially Dodd-Frank, we've become more at the center of all of the data for all of our clients, especially text and message. So our clients are looking for solutions by which they can be compliant with all these regulations and hopefully use us as the central place for all of their compliance needs. So we do want to provide a solution which allow our clients to basically record all of their communication, including text, messages, including audio and video, and then provide them compliance on top of it. And there's a product called Vault that we have built, which allows that for the clients. The other thing that we have done, which is very intentional, is that we don't want to be a telephony company. So we don't really want to provide DITs to our users. We don't want to be any other kind of telecom player. So our architecture has been chosen and been very intentional to make us a data service and not a telecom service. So a lot of our integrations are into the Bloomberg Terminal. So you'll see that it's very seamless with how the Bloomberg Terminal functions. And we've been able to get around some of the regulatory aspects of being a telephony. That covers this, but again, compliance is an important thing, and I really want to emphasize this for anyone who wants to understand what we're doing. So now to talk a little bit about how these workflows look like. IB Talk is the voice room that I talked about. So you basically can go and run IBT. So the terminal basically is like a set of functions and mnemonics that you run. So there's a function for news, there's a function for, or maybe a group of functions for news. There is a function for text, which is IB. There's a function for message, and there are multiple functions for voice. One of the functions is IBT. IBT is used for the audio rooms. You basically get into the room, you can add participants to the room, and it's seamless. You can basically get into a room and you can start talking with each other. Similar to that is IB Live. You can basically get people to accept a request, add them as tiles, and be able to view them. In this case, Aravind did not accept my request, it looks like, but Dennis did. Dennis is the other core developer on my team. This allows you to kind of have presence information and live video information from various participants. This has been actually, it looks a little bit creepy, but really actually has been used a lot by many of our clients. bShare allows you to screen share right from the terminal. As I showed you this kind of workflow where there are multiple different monitors and multiple different terminals, this is very useful to have it on the terminal instead of having like a different solution outside of the terminal and sharing that particular tab. It's actually a seamless way to share from the terminal other tabs to the users. Click to Dial is our telephony solution. We're not going to talk too much about it today, but we did talk about it in Astricon. If you're interested in knowing more about it, please ask Aravind or myself, and we'll be happy to share the slides with you. We basically use Asterix as a backbone for this. Again, the idea is to make telephony seamless with the terminal. This particular integration is with IB, but we also have integrations into functions like Bio, which is like a kind of a social page for all of our users. Bloomberg Room is the new product that is currently internal, which is also going to be released externally. This is based off the Jitsi stack. The reason we went with Jitsi is because it was a full-featured kind of video conferencing solution, and we were kind of behind on that. We didn't have a lot of front-end features that we had developed. So Jitsi gave us everything that we needed, and in 6 months, we actually came up with this product and were able to bring it to market, at least internally. We are planning to get it to clients sometime next year. What does the future look like? We're trying to get all of our different products to kind of interoperate and be seamlessly available across IB. So IB is the flagship text product, so we want to extend text into voice and audio and the various different ways in which voice and audio is used. So we're going to have video presence integrated into IB. We're going to have a popped out experience where people can just have these tiles that people can view at all times. Also have this push to talk capability built into IB. So we're trying to get all of our products to kind of, in some ways, be seamlessly available. Interoperability is something that we haven't looked at yet, but we do want to look at some point. But one of the real kind of goals of this is building out a stack which makes voice available instantly to all of our users at all times. So it's very different from typically use cases like video conferencing meeting use case where actually you build out a new you create a new meeting, and then all the participants join the same room. In our case, people are actually connected as a publisher from their end, but they can actually be part of multiple different rooms, or either audio rooms or video rooms. So that kind of differentiates us in some way with the other stacks. With that, I want to hand it over to Aravind. Hopefully you have some context around what Bloomberg does, what our engineering department is doing, and what kind of workflows we support. Over to Aravind.
Thank you, DJ. Hello, everyone. I'd like to go why we picked WebRTC and why we built the design as we built it. What are some of the challenges we had? And DJ had already mentioned about the 3 stacks. I'll just give a brief introduction on that. And if time permits, that I'd like to go a little bit deeper into our SFU. So as DJ mentioned, the group started around 2011. This was prior to WebRTC. We had a lot of media solution based on Flash, RTMP, and even the GIPs. I'll talk about that later. And Bloomberg, its terminal itself was moving towards a Chromium-based application and moving away from royalty codecs and legacy system. We were also then future-proving for ourselves for being in line with companies shift to web and cloud. The most important thing for us was that, as you saw, that some of the features were all built in originally as they are separate functions, and we wanted to integrate them, and we saw a value proposition in building a common platform. And we needed to have a custom signal plane which was not too heavy and use them only when needed. For example, like a SIP or XMPP, we had to do it only when we wanted to interop with SIP or XMPP clients. And this is where WebRTC was also being only SDP mandating on the signaling was useful for us. 2011, 2012, right at the start of the WebRTC standard. Here I would like to point out that the original version of IBTalk prior around 2011, we were actually working with GIPs. For those people who are familiar, GIPs was sold to Google and was rebranded as WebRTC. So we were already familiar with the WebRTC code base, even though not in the same form there. So we built our solution keeping a lot in mind, mostly our clients. As DJ has already mentioned, that our clients are very wide-ranging and gamut. They have extremely consistent workflows, long-form conversations, researchers and analysts, they just do on long-form. Traders, as you've already seen, are often on short-form conversations, dealing with multiple devices, multiple telephony calls, and oftentimes you do see them interrupt. It made no sense for us, or rather, it made more sense for us to build a common platform in front. Now, traders are extremely notorious for being making sure that their existing workflows are least disrupted. They do not want anything, they don't like new features, or they don't even like new UI changes to be made to their existing workflows. We had to build a solution which had to respect the existing networking requirements. If you do an a Google search for the Bloomberg's port requirements and all that, we actually allow only for opening like 20 to 25 ports between our clients and the Bloomberg services. It's very bespoke. Some of them are beyond SOX 5, some of them are beyond only HTTP proxies, some of them only beyond TCP proxies. The networking requirements are extremely tight. Prior to 2012, all media was going only over TCP. UDP ports were not at all accepted. We then decided that this was good for us to build a system to have the all at the same time use case. What I mean by this is that we kind of saw that our users would be able to be in a long-form conversation, in a video call, viewing somebody else on IB Live, be in an audio chat at the same time, without having to restart the terminal or restart the client, the devices and all that. For us, all these were just different features on a single client. And because it's one client, we needed to build a solution which serviced that one client. Our goal as a group was we had to be as a service model. We still don't know whether we want to be a CPaaS or a platform or an infrastructure as a service model. We think we kind of check all those boxes and sometimes check none of them. But basically, we were catering towards our own clients who are using our product, different groups in Bloomberg who could use our widgets and APIs to build their own products on top of our platform. And we also external clients who could use their services and build and interoperate with our services to augment their own feature set. And finally, the most important thing is Bloomberg is a data company. We try to collect data from the usages in terms of the audit or the actual mining the data from the conversations so that we can provide better value services to our clients. Some of the challenges and constraints which you find our architects and things we ran into. We all know how WebRTC evolved. At the time, Bloomberg, we eventually started moving towards the onboarding, the Chromium terminal started onboarding the WebRTC thing. We were on version 34, but oftentimes the Chromium, the client did not keep up pace with as the standards evolved. This kind of worked both in favor and against us. Favor because we could actually stick with features which were deprecated for a long time. Case in point that we were able to stay with the SDES and not move for DTLS for almost a long time, up to for almost 4 years. The disadvantages was that we could not take advantage of some of the new features and bug fixes in the Chromium stack. Already mentioned about the fact the tightness of network infrastructure and Bloomberg's requirement. Something else which is important, recordings and PII data of the clients. The clients were comfortable only to have them stored in the Bloomberg on-prem, and by on-prem we mean the Bloomberg data center, not necessarily the customer's on-prem. DJ had already mentioned that we are not intending to be a telephony company, so as discussed in Astricon, we defined our telephony solution as a third-party call control. And most importantly is the compliance. We often emphasize this is the biggest thing about Bloomberg. So we built all our solution based on able to track the compliance. Compliance also leads to, in addition to some of the geographical restrictions placed upon VoIP and video over IP legal requirements, we also have our own call admission control limitations mandated by the fact that some companies cannot talk to other companies and so on and so forth. As you did mention, we operate on 3 stacks. Bloomberg Connect is our homegrown SFU, based on C++. I'll be going more in detail on this later. the Jitsi-based video web conferencing solution. This helped us onboard right after COVID and deploy and provide a web-based conferencing solution for our customers, for our employees and eventually customers, and telephony and custom VoIP infrastructure based on Asterix. This provides both dial-in and also certain dial-in to our both our stacks, and also for click-to-dial infrastructure, allowing our customers to talk over telephone. And then most importantly, we built a custom advanced media service offering over the Bloomberg Connect architecture, which entails with, to ensure that we do the compliance-based recording, auditing, and provide advanced media services like transcriptions and summarizing and so on and so forth. So I'd like to go over the Bloomberg Connect architecture, to look at some of the components, and then deeper look into our SFU. The Bloomberg Connect architecture is more like a representative of all the architecture, not just our SFU system. But as you can see that it's at the highest level, you can view it as an N-tiered architecture, 3-tiered, or 4-tiered. At the highest level, we basically have the request processor APIs and events API from clients. Clients are built by our own. Clients are also clients built on top of our SDK. Clients are also third-party clients with whom we federate, like SIP or XMPP client. In the middle tier are basically the application services and ancillary services. DJ had mentioned about the fact that every function, like IB Talk or IB Live, are all separate functions, and each of these application servers actually are application servers for the functions. They're single purposes, and they are subscribed to the best features, best practices of leader failover and stateful. Some of the ancillary services include, we have built, and I'll go in details in the next slide, I'm kind of rushing it. We built our own registration service framework on top of the Bloomberg directory system. We have our own call admission control system to represent and to highlight to respect the info boundary requirements. And this is probably one of the most important component of our architecture, so the stream resource broker. I'll go a little bit in detail, but at the gist of it, this is the one which defines the conferencing topology of the Bloomberg Connect architecture. At the bottom, we have the media relays. The media relays are actually include our own SFU, the Asterix, and an advanced media service platform. We also intend to integrate with the Jitsi-based solution at some level, either through a federation node here or some sort of an architecture still being discussed right now. So these are the components. I forgot to tell one thing. I mean, we do have defined our signaling architecture, and we do it's separated in terms of a client signaling and an internal signaling system. And coming to that, to define the signaling, which is basically derived out of, it's a custom, but we've actually been inspired by RFC 6505, which is the XCON mixer model standard, and also the data model from 6501. The signaling is actually XML and XSP based. We currently support transport over RabbitMQ, Kafka, and WebSocket. Doesn't mean that we have to. Doesn't restrict us from implementing other type of transport. The gist of it is basically to set up a media session. The media session between WebRTC clients and or remote SIP clients. In the future, we are also trying to set up an interoperability with other standard things like XMPP and all that. As I mentioned before, we do own some libraries. So our client-side libraries is a facade wrapper around the WebRTC peer connection and the signaling context. These are basically JavaScript modules used by other users in Bloomberg. We have not exposed it for public usage. And the application servers and ancillary services, we already mentioned about that. One important thing about the ancillary services is that it also handles with a lot of the feature flags in terms of should a call be recorded, should a call be transcribed, and so on and so forth. And of course, the regulatory call admission control. The media broker or stream resource broker is probably one of the most important things for us. Loosely, you can view it as something which the orchestrator of the call is based on the principles defined in the RFC 6917. It's basically defined on connecting or optimal connection of a client. It basically tries to figure out where a client has to join, which relay. It tries to manage the resources, and it also handles the stream topology. By stream topology, there's something where I like to introduce a concept. We don't do it as a conference-based, we view in terms of as publisher-based. The reason for that is that you could be, as I mentioned, at all as a service model, you have a single person who could be with one device, be in IB Live, be subscribers by many subscribers, jump onto a call and and get into a telephony call. We are not having 3 separate instances here, we're having a single instance. So we pin the publisher and we basically orchestrate the network, we pin the publisher, and then we route the subscribers to where the publisher. We also have this we also make sure that the fan out of media between the relays are not duplicated. And I'll get into a bit more detail on that. The media relays, at the core, we have an SFU. We also use Asterisk as a selective forwarder. We're not talking about Asterisk in this one. The gist of it is that it sets up the media pipeline for endpoints and other upstream services. Media relays can cascade each other, which means that if you have a publisher on one media relay and subscriber on another relay, you can basically cascade between them to ensure that people can do that. This is a redundant statement. Telephony is yet another forwarder for us, but what I mean by that is that we also do the same thing for calling out on dialing. We basically view telephony as not as a point-to-point call, but as a meet-me bridge services. And as mentioned before, advanced media processing as a service. 3 important things on that. We basically have built our own standard of how to capture compliance, data for compliance. We capture at individual legs. Every media is individually recorded at the leg level. And advanced media services also takes some time for recording, streaming, and media processing. Since I'm kind of like running away, this is at the highest level. The call flow, to show that there's a custom API over here. We're sending to multiple relays over here. This is standard WebRTC. And this is the most important thing about that is like the media relays this is where we attach the subscribers to say that if you have to be between subscribers on one relay or on another relay. Since I'm running quite quick, I'd like to say a little bit about SFU. We implemented on C++. As I mentioned before, we started working on this way before WebRTC came in. We were working with GIPs. We don't use WebRTC because we found that it was too heavy for our scaling requirements. We only used OpenSSL and libsRTP, and of course Bloomberg's own BDE network. We support the basic free functionalities. We don't support simulcast and SVC for now, but because we don't have the need for that in the closed system, but it is in the works right now. We also implemented custom protocols, as I mentioned before, for capture and recording. It is also kind of like based on the MRCP standard. At the core, the relay is basically, the core is an SFU, but we also support mixing of audios upon demand. A relay can basically cascade over both secure and insecure network, and then it basically builds as a dynamic pipeline concept. I know I'm kind of rushing things over here because it's telling me the time is up. This is the contextual dynamic pipeline for a relay. You can view it as there are 3 types of sockets. Peer sockets was basically where a publisher and subscribers would be. A linked socket is where a relay was probably cascading with another relay. You can view it as a pipeline-based architecture. People who are familiar with GStreamer and all that know what it is. In the sense, it's just that this pipeline architecture allows us to ingest dynamic functionalities in terms of building custom filters and all that. I'm going to rush for certain things, but some notables. We do SRC rewriting. This is something which is very important for us because we use it for distributed tracing on the subscriber side, and we also use it as a foundation for the last end speakers. There are some, as I mentioned before, it's already leg-level media capture. This is also another important thing for us. Because of the way the networks are tight and bespoke, and the relays are the SFUs are the ICE controlling agent, slightly different from a typical video conferencing where you can have the client can also be the offerer, can be offerer. So we kind of dial out to the clients and instantiate a DTLS exchange. And most importantly is the fact that we only cascade dominant speakers from each relay. We don't necessarily do flood all the practice between different relays on that. Here, I'd like to show a simple context. As an example pipeline flow, this is basically a publisher has been saying that, okay, it has two sets of subscribers, one on the same relay and one on the different relay. Relay link has been created. This has been defined and identified by the broker to say that, okay, the subscriber has been pinned onto some other relay, so we automatically create a relay, a link relay. I had mentioned before that relaying can be done both over RTP and SRTP. This has been defined that it's a safe one, so we are just forwarding the RTP packets. It is called, publisher has also been recorded, both for either for capture, the leg is being captured, the filter is dynamically ingested on that, and then it's also be streaming or to an aux stream to a remote streamer. That's also dynamically being sent, but it's being sent as a raw file, and this is being sent up as this is being sent as a SRTP packet. And of course, the PSR basically is. I know I had to rush a lot. The time was there, but thank you so much, and I'll hand it back to DJ for the final items.
Thanks. Thank you, Aravind. We are eating into the Q&A. I'm hoping we have some time, right? But probably eating into the Q&A, but I'll make it quick. So in terms of future plans, we are actively working on a few projects. We are adding the voice capability into our text system called IB. We are extending and scaling out our SFE so that we can support up to 10K users per room. We're also releasing Bloomberg Room to clients next year. So this is the stack that was based on Jitsi. We're also focused a lot on recording of the next 6 months. So we are going to look into SIP-REC for recording for telephony. We're also looking at a gateway model where we can potentially interoperate with between Jitsi and with our stack so that we can do recording. Yeah, just a quick set of things we're working on. Apart from this, we're also working on some experimental projects that we can talk about in the next ComCon. So thank you very much for your attention. Just a quick plug, we do have an opening in SF, and we are looking actively for a backend engineer. So if anyone in your network is interested, please send them along. At this point, I guess we're open for questions.
Are there any questions from the audience?
Hi. So you did mention that you have a long-running video product where people stay on call for a long time, and you have an audio solution as well, which is on RTC, or is that just telephony?
So we have a few audio solutions, right? So there's the IB Talk solution, which is based on WebRTC, and there's a telephony solution called Click to Dial.
Understood. And you mentioned something called media pinning earlier. So does that mean that when you have your room solution rolled out, you have this long-running video rolled out, and you have this IB Talk rolled out, all of these streams are actually going to be maintained and published to all subscribers in all three of these products?
It depends on the application, right? So if you are not interested, if you are interested only on IB Live and you want to see what I am, but I'm in a call with Luca and DJ, so I'm only publishing once. So, but the streamers will be routed to, my audio will be going over there. Now, yes, technically you could hear my audio as I'm talking to them, but that will defer it to application. So the application will be smart enough to say that, okay, just mute this call, thing, and so we will be instructed. The pipeline itself is, well, it's meant to be a pipeline, so it's meant to be driven by the application. So the goal would be that, okay, you'll be mute, the application will be smart enough to mute you and have a conference on that. Or you may be able to hear the conference also. So.
Just to add to that, so IB Talk is available for all Bloomberg subscribers, right? So once you get into the Bloomberg terminal, you've logged into, if you kind of run IBT, you're logged into this solution, and you are at that point able to view or using IB Live or listen using IB Talk to any other publisher on the Bloomberg terminal. Bloomberg Room is separate. Bloomberg Room is basically room-based, so only the people who have kind of signed up to go into a particular room can hear that room, right? Same thing with IBT and IBL, but the real thing is that there's a lot more capability around publishing to various different rooms and various different channels using IBT currently, because every terminal subscriber automatically has access to BCT. It doesn't necessarily have access to room currently. But our eventual goal is to have interoperability so that you can seamlessly go between one room and another. You can turn on audio, say in room, and then you can probably get video into, say, IB Live from room and so on. So the interoperability bit is going to be very interesting. That's the federation aspect of things, which is probably going to come later in 2024, not right now.
Thank you.
Hi. You mentioned compliance. I was wondering what are some of the security requirements that would apply specifically to you that go beyond the normal network transport encryption. What are the interesting things that compliance asks for?
Yeah, so I know a few of them. There's still a kind of a work in progress because the legalities with this are not really very clear around voice and video, especially with video, actually. But a few things that we are definitely going to do is to have worm storage so that there is persistent storage used for storing all of audio and video. We don't want to have any tampering of audio and video. So we want to have recording at the source as much as possible. So we're trying to get channels directly into JVB from Jitsi, into our SFU, so that we can basically record from the source as much as possible. There are other requirements around leg-based recording. So it's basically like we cannot have like mixed recording across all of our users. Every leg needs to be recorded separately and also transcribed in the future. So we need to kind of have all those levels of like capabilities available. So our BCT stack already supports leg-based recording, and we have spent like more than a year working on that. Room currently doesn't have that, so we have a project in play right now with the Jitsi folks to kind of do leg-based recording. So those are the few things that we've worked on. But there probably are going to be more regulations around this. So Sandro, we'll be in touch. I'll let you know.
Thank you very much.
I'd like to
We're
add one
out
more thing on
of
that.
time, but
Arvind wants to add something.
Yeah, I'd like
to
to
that.
add one more thing on that. There's something we want to work with the standards body, because as far as the Dodd-Frank rule says that it cannot be tampered, we don't know whether it means that the RTP headers cannot be changed. You can't have like a recording server sitting elsewhere, which is something the tech people know that. So the standards have not caught up with the tech capture yet. So this is something Bloomberg wants to take a lead on that, and probably will work with the industry veterans yet on to do that. So as the rest are pretty much the same on that. So we don't know if a recording server has to be, the RTP header can be rewritten or the SOS. So those are the things we have to figure out on that. So.
thank you very much for the very interesting presentation. We have more questions, but we'll ask them offline.
Of course.
So thank you so much.
Thank you, guys.